Hello everyone, welcome to Lectrick YouTube channel. In this video, we are covering what are resistors. So introduction to resistors in detail. Let's begin. So this is the contents which we are going to look into today, and what are resistors and its uses, and what are its characteristics, and when the resistors are connected in parallel or series, how it will behave, when the temperature will change, then what is the effect to the that resistance. Then high frequency is applying to the resistor, then how it will behave. Then what is voltage coefficient of resistance and power rating and derating curves, and how we need to calculate voltage rating of a resistors, and how to identify a resistor with the use of colors, and what are the main types of resistors, and like fixed variable, like so what are wire wound resistor, composition resistors, and metal film resistors, potentiometers, and rheostat. And probably you might have used this rheostat like in your motor controller lab, electrical machines lab, yeah, many and networks lab, like that. And special purpose resistors and thermistors also we will look into it. So all the things which related to resistors we are covering here. So what is resistance, or what are resistor? When we say resistor, it is a device. Okay, so it is an electrical device. What it will do, it will always offers a resistance to the flow of electric current. Then what is resistance? Resistance is a effect, so that means it is the magnitude of opposition to the flow of current. So it won't allow the flow of current in it, so it will always offers a resistance. That's why it is called resistance. So this is a property of a resistor. When we say a larger resistance value indicates greater opposition to the flow of current. That means if having one resistor of 1 ohm and another resistors of 10 ohm, means 10 ohm resistor have offers a greater opposition to the flow of current. Then resistance is generally measured in ohms and denoted by symbol omega. And we'll go to the uses of resistors, where it is using resistors. Everywhere, we can say everywhere in any electronic circuit, electrical circuit, resistors are used with different rating and different power ratings and capacity. So various uses like setting biases, controlling gain, and fixing time constant, like time constant depends on resistance also. Then matching and loading circuits, and voltage division like voltage divider. So heat generation, like we can use for cooking food also, like in by using resistor, like by using nichrome wire. So these are like few uses of resistors. Let's move to the next slide. So in the voltage and current characteristics of resistor, so what resistance will depend. One is resistance is directly proportional to the resistance of a material and length of the resistor. When the length increases, the resistance also increases. When resistivity of a material, so each and every material having different resistivity. So resistivity, what is resistivity? We will in the next slide we will cover. So resistivity is measured in ohm meter. Ohm meter we need to measure, and area is area of cross section in length in meter. This is ohm meter. So this is resistance, total resistance of a conductor. That means in the next slide we will see. So you see this is a conduct, this is a resist, this is one element, it is having one resistance R. Then when the cross sectional area, this A is there, no, this in the cross sectional area, that means for example I'm having one more one more resistive element, so having greater cross sectional area, this is cross sectional area. So compared to this is bigger size. That means resistance will decrease, but when the length increases, the resistance also will increases. As here I mentioned, the length increases directly proportional. That means both will both when both these both will increase, resistance will increase, and this is inversely proportional. That means when area of cross section will decrease, the resistance of a resistor also will decrease. So this is by using Ohm's law, you will get to know R is equal to V by, that means voltage by current. So by using this, if you know the voltage and if you know the current in a circuit, you can easily find out the resistance. That means you know the voltage applied across it, and you know the current, the value of current flowing through it. So then you can easily find out the resistance. All the resistance dissipates power when a voltage is applied. The power dissipated by the resistor is represented by P is equal to V square by R. So this formula is also very important in any MCQ type questions. So based on the voltage rating and resistance of an element, you can easily find out the power dissipated by the resistor. So by using P and V square also you can find out R, that is R is equal to V square by P. And this is in an ideal resistor dissipates electrical energy without storing electric or magnetic energy. That means, so ideal resistor, we are talking about ideal resistor here. Ideal resistor means, I will show you, this is a resistor, ideal resistor. That means it is having only resistive components. There is no inductive and capacitive components. So that is ideal resistor. Then what are normal general resistor? We will talk about in the next high frequency effect slide. Really we are talking it won't store any electrical or magnetic energy. Then what are like in the resistor networks, when several resistors are connected in networks in a series, for example, show you, for example, when resistors are connected in series, so this is my R1 and this is my R2. Then when resistors are connected in parallel, so here you see this is also R1 and R2. If the resistors are joined in series, the effective resistance is the sum of individual resistance. That means this sentence will tells this formula. That means when the resistors are connected in series, so resistance will increase, total resistance. When the resistance are connected in parallel, the same resistance are connected in parallel, the resistance will decrease. The resistance, when we talk about temperature with respect to resistance, that means when the temperature varies, then the resistance also will change. So Ohm's law also will tell same thing. So we're directly proportional to voltage and inversely proportional, that R is equal to V by I. Ohm's law will tells you that R is equal to V by I. That means resistance of a conductor is directly proportional to its voltage and inversely proportional to its current flowing through the conductor. Temperature is constant. That means same temperature, then only this formula holds good. That means when what if temperature will change? So when the temperature will change, obviously the resistance will also, value of the resistance will also affect. The temperature coefficient of electrical resistance is the change in resistance of a conductor per unit change in temperature. So it is measured in omega per degree centigrade, and temperature coefficient of resistance will be two types. One is positive temperature coefficient of resistance and another one is negative temperature coefficient of resistance. So in the positive temperature coefficient of denotes a rise in resistance with a rise in temperature. When the temperature will increase, resistance also will increase. Negative temperature of, for example, okay, this is increase, this is decrease. Negative temperature coefficient of resistance is denotes an decrease in resistance with a rise in temperature. And pure metals will have positive some temperature coefficient of resistance, and some metals like constantine and manganese have zero temperature coefficient of resistance. That means there is no change. If you increase the temperature, if you decrease the temperature, there is no effect for these elements, so it will behave like that. Means it the resistance will be remain constant across, even though if you change the temperature. Then so few elements like carbon and graphites usually exhibits negative temperature coefficient of resistance. So this is the formula. Like if you want to calculate the new temperature resistance, new resistance based on temperature, like R1, this R1 like with respect to T1, what is your like temperature 1 resistance? It is generally like reference temperature we can take, like usually 20 degrees centigrade. At 20 degrees centigrade, what is your resistance of that material? When the temperature changes to, for example, 40 degrees centigrade, so what you like based on this formula, you need to calculate this. So this is alpha T1 is the temperature coefficient of electrical resistance. So based on this, you need to calculate, and you will get the new temperature coefficient of resistance. So this is high frequency effect. As I in the previous slides, as I told you, so ideal resistor dissipates only electrical energy without any storage of electrical or magnetic energy. Then R, L and C is there. So even though we are considering R, L and C components will come based on the because of the elements property, that is components property. Why? The resistors show a change in their resistance value when subjected to AC voltage. When the AC voltage applied across it, there is a change in resistance with voltage frequency. That is known as Boyle effect. Why Boyle effect will occurs? Because all the resistors of some inductance and some capacitance along with the resistive components. Because of this reason, when the AC voltages applied across it, inductor and capacitor will store magnetic and electrical energies. And that's why high frequency effect. Because of that reason, Boyle effect will occur. That's why smaller the diameter of the resistor, the better is the frequency response. So when we talk about the diameter of the resistor, so if it is less means the frequency response will be better. That's why if your length of a resistor is 4 centimeter, then diameter should be 1. And this is voltage coefficient of resistance. That means resistance also not always independent of applied voltage. Voltage coefficient of resistance is the change in resistance per unit change in voltage. When the resistance, when the voltage changes, resistance also will vary. Voltage coefficient is given by the relationship voltage coefficient is equal to 100 into R1 minus R2 divided by R2 into V1 minus V2, where R1 is resistance at the rated voltage at V1, R2 is the resistance at 10% of rated voltage at V2. By using this formula, you can calculate voltage coefficient of resistance. Thank you for watching. In the next video, we will cover remaining topics like types and in details. Stay tuned. If you have any doubts, please write it in the comment section. In the comment box, please mention your comments and please like this video. Thank you for watching from the Lectrick team. Remaining things we will continue in the next video. Thank you for watching. Have a good day.